Hello. Today we're going to review the rules and methods by which an intestate decedent's estate will be distributed with regards to the decedent's issue. In order to work through this unit, we will need a few things to help us. We're going to need some facts, which mostly are going to come from a family diagram. We're also going to need a method to work through all of the issue and to figure out what their shares are. We'll also need a couple of rules, which we'll come to understand better as we apply them. The method is relatively straightforward, and in many fact patterns is even easy. Nevertheless, it's important to break the method down and be sure that you're following the correct method, because when these problems become factually complex, it's very easy to go off the rails quite quickly. Our method involves 4 basic steps. First of all, we have to identify the starting generation, that is, the generation at which we're going to make the initial allocation of shares. The specific rule for identifying the starting generation varies to some degree depending on which system you're under, and we'll cover that more in a moment. Secondly, we have to actually make the initial allocation of shares. We do this by applying something that I call the rule, another thing that we will get to in just a moment. Third, if despite this initial allocation of shares, we haven't been able to distribute all of the estate, the facts will help us understand why in a moment, then we have to take whatever we didn't distribute and drop that portion down to the next generation. Precisely how we make this drop to the subsequent generation is also specified by a rule that is specific to the system that we're studying. Then you just keep doing this method as many times as you need to, over as many generations as required, until you have distributed all of the estate. The rules that we need include the rule that governs the initial allocation of shares, which we call the rule. And then, with regard to each system, there are these 2 system-specific rules that I mentioned in the previous slide. First, we have to have a rule that helps us to identify the starting generation under that system. And then we also need a rule about how to handle that dropping of shares to a subsequent generation when we need to do that. The rule governs the initial allocation of shares at the starting generation. You must memorize this. This will be your surest help in times of trouble and complicated facts. The rule states that we allocate 1 share for each member of that generation, that is the starting generation, then living, and 1 share for each deceased member of that generation, leaving issue, then living. This rule will become much clearer when we apply it. You'll find on the twin page for this class a table that walks you through the steps of the method with each of the 3 systems we're going to study. And for those of you who are more of a table text kind of person, you may find this chart helpful. Most people, however, learn this material best by actually walking through several problems and applying the method. Each time we do this, we're going to need a family diagram such as this one. Each time we walk through this process, we're going to need a set of facts telling us who is alive and who's not alive on the day or the moment when we're doing this division. One of the things you need to remember is that our focus is always from the point of view of D, the decedent in the particular intestate estate which we are discussing. The decedent, I hope you will understand, is always dead. That's why we call him a decedent. Now, with regard to our initial set of facts, as I said, primarily the facts we need to know are who's alive and who's not at the moment that the decedent dies. For our very first example, we're going to assume that everyone pictured in this diagram is alive on the day the decedent dies. This is the easiest example possible. In fact, it's so easy, it's going to make you think we don't even need a method or any rules. But this is not the kind of situation where we developed these rules. We developed the rules in more complex situations. We'll just save the more complex examples until after we've mastered the basics. We're also going to start with the oldest form of distribution, which is called persterpes. Persterpes means by the roots, and that is in reference to family trees. And the name will help you remember the system-specific rules, because those system-specific rules are designed to preference family lineage over generational equity. We'll see more about that as we compare the systems. So, here we are with our nice little family, and D has recently passed away, and we are going to, first of all, identify the starting generation. The starting generation in a persterpes system is always the child generation. It is always the child generation, whether there are any children who live past the moment that D died or not. That is, whether there are any living members of the child generation or not, you always start with the child generation for persterpes. Always, always, always. Next, we apply the rule. The rule says we give one share, we allocate one share for each member of that generation then living. According to the facts of our problem, everyone is still living, and so we allocate one share to A, one share to B, one share to C. Now there is a second half of the rule, but if all the members of the starting generation are then living, we don't really have to worry about the second half of the rule yet. All right, so having allocated shares to the members of the starting generation, we need to know what fraction corresponds to that allocation. And this is the part where, as I said, you're going to think that this is so simple, you can't possibly need a method to figure this out. Nonetheless, we're walking through the method so that you know it for a more complicated problem. Well, how many shares did we allocate? That's easy enough. Count them. 1, 2, 3. That gives you the denominator of the fraction that will describe each share that we've allocated. Thus, now, each of them is getting one of those shares, and voila, we know that A gets 1/3 of D's estate, B gets 1/3 of D's estate, and C gets 1/3 of D's estate. As I said, when the facts are simple, it looks as though you don't even need this method. But let's notice a few things that come out of this apparently obvious solution. One is, you'll notice that no one below this line is getting anything. That's a rule we call the ancestor rule, which states that if your immediate lineal ancestor took a share of the decedent's estate, then you don't get anything. Or to say in another way, if your parent got a share, then you get none. None of the descendants of D lower than the child generation are allocated a share of D's estate, because all of the shares have been allocated at the starting generation. That was simple enough. Let's try a more complicated problem. We need to kill somebody off in the child generation. Let's pick C for no better reason than because it occurs to me that that would be a good way to go right now. Okay, we're still under persterpes, and so we still need to identify the starting generation in the same way, which is to say it is always the child generation. That is this generation right here, one below the decedent. Next, we apply the rule. One share for each member of that generation then living. That takes care of A and B. Then we do need the second half of the rule to handle C's share. And the rule says one share for each deceased member leaving issue then living. So we look at C. C is a deceased member of the starting generation. Did C leave any issue then living? Yes, indeed. And therefore, we're going to allocate a share to C, even though C is not there to receive it. How do we know the fractions? Same way as before. We count up all the shares, and that gives us the denominator of our fraction, and then each of these shares allocated is 1. So we still have 1/3 of D's estate going to A, and 1/3 of D's estate going to B. But when we get ready to hand out the 1/3 we allocated to C, we have a problem because C is dead. And dead men not only cannot wear plaid, they can't take shares of intestate estates either. So what do we do with this 1/3? Well, this is where we're going to drop down to a subsequent generation. How we handle the assets will be determined according to a system-specific rule, in this case, the system being per stirpes. I mentioned earlier that per stirpes means by the roots, and that it is a system that preferences family tree, that is the family line, above generational equity. So you'll notice that 5 and 6 are not the only people at the grandchild generation relative to D, but we don't care because the fact that we're under per stirpes means that it's as though there's a fence or some sort of barrier between the different family lines. Thus, we're really only worried about dropping down C's share, and we can only drop it down to C's issue. All right, so we go down one more generation, and now we're going to apply the rule again with regard to this generation, as if this 1/3 share here were the whole world. All right, so apply the rule again, 1 share for each member of that generation then living. Well, we don't need any further the second half of the rule because 5 and 6 are both still living. How many shares have we allocated? Now notice this is not the ultimate question, it's just with regard to this particular division at this generation. 1, 2. All right, so our denominator is 2. And because we have one person who's getting each of those shares, we're getting 1/2 to each of them. But notice it's not 1/2 of D's estate, it is 1/2 of C's 1/3 share. Now, for those of you who are math challenged, when we encounter the word of in text, that's an indication that we need to do multiplication. So 5 is going to get 1/2 of C's 1/3 share, and 6 is going to get 1/2 of C's 1/3 share. We do the math, and what we come up with is 1/2 times 1/3 equals 1/6 to 5 and 1/6 to 6. That is 1/6 of D's estate. And so there's your answer to this slightly more complicated problem. A takes 1/3, B takes 1/3, 5 takes 1/6, 6 takes 1/6, and that's it. We're out of assets, and so we don't have to drop down to any subsequent generations. If we start with a new, fresh family tree, we can try killing somebody else off and see how that's going to change the math. This time, let's kill B and see how it works out. Once again, the starting generation in per stirpes is the child generation, and so we apply the rule. 1 share for each member of that generation then living, that's 2, and 1 share for each deceased member of that generation, leaving issue then living. Well, B is deceased, but does have 1 child living, who's 4. All right, so our initial allocation of shares, we again get thirds, 1/3 to A, 1/3 to C. We distribute their shares and say, bye-bye, thanks for playing, and send them on their merry way, and we don't think about them anymore. We do have to worry, though, what we're going to do with this 1/3 share allocated to B. We look at what the share that B has, we drop it down to the next generation, and remember, we're looking only at B's family tree, not any other members of the grandchild generation. Well, this is so simple, even I probably am not going to step through the entire rule, but 1 share for each member of that generation then living means that 4 is the only one. That means we have a 1/1 share times 1/3. In other words, that entire 1/3 share is going to devolve to number 4 there. Again, not very difficult. But notice that in this problem, 4 is going to get the entire 1/3 share, whereas in our previous problem, 5 and 6 had to split C's 1/3 share. All right, I guess you can probably guess where this is going. If it had been the case that C had predeceased as well, we'd do the same process that we did previously with C's 1/3 share, and we would end up with 5 and 6 each getting 1/2 of C's 1/3, same as we did before, 1/6 each. Now, as between 4, 5, and 6, you can imagine who's going to be grumpy at the next family reunion. 5 and 6 each only got 1/6, while 4 got the entire share that had initially been allocated for B. That's because the allocations are for the family tree of that child, not for them really as individuals. Their children stand in their shoes by representation, as we say, and so they are only able to split whatever it was that their parent had been allocated. All right, there's a major variation on the traditional per stirpes system. If we have to call the old version something, we'll call it strict per stirpes. There is another version called modern per stirpes. The difference has to do only with the rule by which you identify the starting generation. Now, you'll remember I said that in strict per stirpes, we always start with the child generation, whether anyone in that generation is living or not. Thus, even if it were the case that A, B, and C had all predeceased D, we would still make our initial allocation of shares at the starting generation of the child generation. And we would still come up with 1/3 for each of those family trees because that was where we made our initial allocation. All of them are predeceased, but they all left living issue. However, under modern per stirpes, we start with the first generation with any living members. In a case like the one we're looking at now, we would not start at the child generation because it has no living members. Instead, we would come down and start at the grandchild generation because that's the first generation below the decedent that has any living members. Now we apply the rule the same as we did before, 1 share for each member of that generation then living. And since they're all still alive, we don't have to worry about the second part of the rule. How many shares have we allocated? Well, this time we've allocated 6 shares straight across the board, just the way these grandchildren are numbered. And so our fraction in this problem is going to be 1/6. And that will be true for 2 and 3 and 4 and 5 and 6. They each will get 1/6 of D's estate. Now, this is still a per stirpes system, so the fact that they're each getting 1/6 is really a function of the difference with regard to the starting generation. That is, when we were in strict per stirpes, we started up here, so we got 3 shares in our initial allocation. Now, however, we are in modern per stirpes. We can't start here because that generation has no living members. So we do the same method, but we're doing it starting with the next generation down. And that creates what appears to be generational equity, but it really is a function more of the starting generation rule. To make this point more clear, let's imagine that C has predeceased and B has predeceased. Which generation do we start with? Well, under strict per stirpes, we always start at the child generation. And so, as we've seen in some previous slides, we would begin with the child generation right there. Under modern per stirpes, the rule is you start with the first generation with any living members. Well, A is still alive and kicking there, so we would still start with the child generation in this scenario. And so, unlike our previous slide where we had 1/6 to each of these, we would end up with something that was like what we did a couple of slides ago. We'd be preferencing these family trees, and we would be making our initial allocation based on this generation, giving us 1/3 for each of them, and those thirds would then be dropped down and divided, but per the family tree. So again, we have B getting 1/3, 5 getting 1/6, and 6 getting 1/6 because of the math of it. Thus, sometimes grandchildren do get shares, but what share they get precisely depends entirely on the starting generation, and then how many of them are within a particular family tree. Now, as I mentioned, most of these fact patterns have been fairly simple, but I'm sure that you can imagine that if we go through here and kill off people more or less at random, we can get some very different outcomes depending on whom we've killed and what their family situation is. Let's take this for example. Now, we apply the rule. First of all, we identify the starting generation. Now, B is still alive, and so we'd get the same starting generation whether it's strict per stirpes or modern per stirpes. We would still allocate 1 share for each member of that generation then living and 1 share for each deceased member leaving issue then living, and we really wouldn't get any particularly different outcome. The difference primarily would show up with regard to C's share. Remember, we've got 1/3 that we're allocating across the board at the child generation. When we drop down C's 1/3 to the next generation and apply the rule, we have 1 share for each member of that generation then living. Now, 6 has died, but again, 6 has some living issue. So 6 still gets a share allocated. The difference is that the 1/2 of 1/3 will stay with 5 because of the ancestor rule, whereas 6's share is going to have to be dropped down to H. Because H is the only living issue of 6, H will get all of 6's share, which is 1/6. And so then you will be done. You'll have 1/6 for H, 1/6 for 5, 1/3 for B, and 1/3 for A. In another variation, let's imagine that we have B and C who have died, but let's also imagine that 4 are predeceased, some sort of terrible family car crash, I'm sure. Now, in this situation, you'll have to be careful to notice we're going to start at the same generation, whether per stirpes or modern per stirpes, the first generation with living issue for modern per stirpes and the child generation for strict per stirpes. We have 1 share for each living member of that generation, that's A, and 1 share for each deceased member leaving issue then living. Well, C is deceased and left some living issue, but look at B. B had issue, but that issue also predeceased D. So B doesn't qualify to have a share allocated because B is a deceased member of that generation who did not leave issue then living. That means we only have 2 shares that are going out in this initial allocation, half to A and half to C's family. That half share for C, because C is predeceased, again, we'll have to drop down C's family line, and so again we'll have 1/2 of that share going to each of 5 and 6, so each of them will get 1/4 of D's estate. So again, none of these particular scenarios are themselves terribly difficult. The trick is that you have to be sure that you don't lose sight of the application of the rules just because you have recently done several examples that are much easier. All right, I think we've done enough with the 2 different stirpital systems. It's time now to look at the rule that applies under the Uniform Probate Code, which is per capita at each generation. Now, per capita at each generation is distinguished from either of the stirpital systems in that the preference is less for family trees and is more about generational equity. It requires a different rule with regard to how you drop assets down to a subsequent generation. But it still uses the same rule for the initial allocation of shares. That is, 1 share for each member of that generation then living, and 1 share for each deceased member leaving issue then living. It also uses the modern per stirpes rule with regard to the starting generation. That is, we start at the first generation with living members. Now, one of the things that you will observe as we walk through this is that there are a lot of fact patterns where you'll get the exact same outcome whether you are under strict per stirpes, modern per stirpes, or per capita at each generation. The methods are actually different, but the outcomes can be the same. All right, so in order to see per capita at each generation really truly in work, we're going to have to kill off at least 2 members of the starting generation, and you'll see why in just a moment. So let's kill B and C again. I know I'm picking on them, but they're just the ones I'm picking on today. All right, our initial generation, our starting generation, is the first generation with living members under per capita, and that will be this generation, the child generation, which is just coincidence because there is a living member, and that's A. We apply the rule again, 1 share for each member of that generation then living, and then 1 share for each deceased member of that generation leaving issue then living. So once again, we have 1/3 shares for each member of the starting generation. We give A's 1/3 share, and then that's it under the ancestor rule. 1, 2, and 3, and for that matter, little a, little b, little c, little d are all out of the running now, because if your parent takes a share, then you get none. But we have to figure out what we're going to do with the 1/3 share that B can't take and the 1/3 share that was allocated to C. We're going to do something a little bit different in the case of per capita at each generation. We apply a system rule for allocating or dropping down the assets to the next generation that I call bundle and drop. Let's start with the bundling. We have a 1/3 share that we couldn't pay to B because B is dead. We have another 1/3 share that we couldn't pay to C because C is dead. We're going to bundle these together, that is, add them, and what we'll get once we do that is 2/3 of D's estate. That is what we're going to drop down to the next generation. And aside from the operation of the ancestor rule, which rules out 1, 2, and 3, we're going to treat every member of this grandchild generation exactly the same, that is, without regard to the family lineage. We don't care that 4 is a child of B and 5 and 6 are both children of C. We're taking that entire 2/3 amount and dropping it down to the next generation. Now we apply the rule again, 1 share for each member of that generation then living. We don't have to worry about the second half. So let's see what we've got. We've got 3 people again, and so they each are going to get 1/3, but it's going to be 1/3 of that bundled share, not the 1/3 of 1/3. So we would have 1/3 of 2/3 for each of them. If you do the math, what you come up with is 2/9, and that is the answer. That is the share that 4 will get, and 5 will get, and 6 will get. So our final answer in this situation would be that A gets 1/3 of D's estate, 4 gets 2/9, 5 gets 2/9, and 6 gets 2/9. And that would be it if we add it all up. If we're able to play with fractions that much, we would find that we have exhausted the estate, and so there's no more assets to drop to any remaining, to any subsequent generations. We also know that E, F, G, and H aren't going to qualify simply because their parent took a share, and so they're going to get none. Now, as I mentioned, sometimes you will get the exact same outcome regardless of the system you're under. So let's imagine, again, as we did in a previous example, that B has predeceased the decedent, so that we have this situation where A and C are living members of the child generation. Well, what's our starting generation? Under strict persterpes, it's the child generation, always, always, always. And there you go. Under modern persterpes, it's the first generation with living members. Guess what? That's also the child generation. Under per capita at each generation, it is, again, the first generation with living members. That would, again, be the child generation. 3 systems, 3 different rules. We still end up starting at the child generation. In all systems, we apply the basic rule for initial allocation, 1 share for each member of that generation then living, and 1 share for each deceased member leaving issue then living. We give A that 1/3 share and say, bye-bye, thanks for playing, same with C, and they're out of here. B's 1/3 share, of course, has to drop down to the next generation. But notice what happens. If we're under strict or modern persterpes, we would be preferencing the family tree, and that would mean that B's 1/3 share could only go to B's issue. But if we're under per capita at each generation, where we're preferencing generational equity, we still would not be giving anything to 1, 2, 3, or 5, and 6 because of the ancestor rule. Their parents took a share, so they get none. So under a per capita at each generation system, we would still get 1/3 dropping down to number 4. That is, you would get the same outcome in this problem, 1/3 to A, 1/3 to 4, and 1/3 to C, regardless of which of the 3 systems you might be applying. And this is going to be true in every fact pattern. You have to be mindful that sometimes you do get exactly the same outcome. If we think back to our first example, the very simple one where A, B, and C were all alive, in fact everybody was still alive except the decedent, you would always get the exact same answer whether you're under strict persterpes, modern persterpes, or per capita at each generation. If it were the case that you had killed off not only B but also 4, you would get the same answer whether you're under strict persterpes, modern persterpes, or per capita at each generation, because under all of those, the single rule we have for initial allocation would not include B. Similarly, if anybody in the starting generation has predeceased, but only one of them, then you're going to get the same outcome under all 3 systems because you don't have more than 1 share to bundle under per capita. That is, we would have 1/3 to A, 1/3 to B, and 1/3 to C. You drop it down to C's family under the stirpital systems. You drop it down by generation under the per capita at each generation system. But in any of those 3 cases, you still just have 1/3 share. And so you're still going to drop it down in the same way regardless of which of those systems. So in order to really have a distinction, you have to be aware that certain facts would have to be present. That is, you would never start with any generation other than the child generation in any of the 3 systems unless it was the case that all 3 members of that generation had predeceased the decedent. That's the only time that under modern persterpes or under per capita at each generation, you would begin your initial allocation at the next generation down. In addition to that, we have to be aware that unless you have more than 1 member of the starting generation predeceased and they both had living issue that they left, per capita at each generation won't give you any different outcome either. So again, as we said before, if you imagine that 4 has predeceased the decedent, you would end up with 1/2 to A, 1/2 to C, and even with C having predeceased, you wouldn't have any difference in the way that showed up at the next generation, whether you're in strict persterpes, modern persterpes, or per capita at each generation. The best way to learn this material is to practice. When you look on the twin page, you'll find that I have uploaded a copy of this diagram. My recommendation to you is that you go ahead and squander some of your printing credits or spend some money and spit out a bunch of these. And then sit around and just randomly kill people off, depending on the whims of the day, and see what kind of impact, if any, that has on the distribution. After you've killed a few people off, work out the diagram under strict persterpes, then work it out under modern persterpes, and then work it out under per capita at each generation, and you will quickly come to realize the different ways that the three systems operate. In addition, if you go look on YouTube, you'll find that I have uploaded a different video example of per capita at each generation using a problem that I believe Barbary actually gave to students a couple of years ago during the summer bar prep class. That will give you a little more insight into the per capita at each generation distribution method, which was what they were covering in the Barbary class that day. That will give you yet another way to look at the working out of these examples. And other than that, we're done.